back to section 6.4, part 2 of Precalculus. You're really going to enjoy this one. We get to do some more graphing. And now I introduce you to Mr. Peer. Hello, Mr. Peer.
Why, hello, and thank you for the introduction. And, this is 6.4, part 2. Be sure you see part 1. The assignment, of course, you want to check out your assignment from page, whatever page that assignment was on, the one that's due at the same time that I send this one out. So make sure you've done the old assignment. Okay, enough babbling. We continue on. We are on about page 392. Oh, I want to point out one small error in the book. If you look at page 388, and yeah, you should have your book handy, really. If you look at page 388, there's a potential confusion there. They have a graph that looks like this, and they've got 1 marked up here, and they've got a sine function that has an amplitude of 1, and they have it rising about this high and going back down, and they give you the coordinates of this point as being pi over 2, 1. Okay, and you say, wait a minute, that's not pi over 2, 1. What's going on? Am I confused? No, you're not confused. Whoever wrote the book was confused. We have this, that's in figure 46. Same thing happens in figure 47. They're not in proper alignment. Now figure 47b is good. Figure 47c is not bad. Even figure 46b is okay. But there are 2 diagrams there in the book where they really messed up on their alignment. So don't let that bother you. Okay. Now, I want to remind you of a very important little detail here, and that is this. If we have something like y equals 3 times the sine of 4x, taking this from the top of the page here, what is the amplitude of this function? Yep, amplitude is 3. This thing will rise to a height of 3 up here, and it'll go down to the depths of -3 down there. And how about its a period? Do you remember how to do the period? The period is equal to, and we refer to that as t, yt, I do not know. But the period is 2 pi divided by omega. What's omega? Omega is the coefficient of x right there. So in this particular case, the period would be 2 pi over 4, better known as 1/2 pi. So this function has an amplitude of 3 and a period of pi over 2, using this simple formula, 2 pi over omega for a period. Let's take a moment to see what that graph might look like. Well, how about more than just a moment? Let's go to my next screen here where I have a trigonometry coordinate plane. And, oh, there's not enough room to graph that. Since there's not enough room to graph it, let's change functions. Let's do y equals 2 times the sine of, and what was that function again? I've already forgotten what it was. Times the sine of 4x. 2 times the sine of 4x. By the way, that is our goal for today, to take functions like this and graph them, which is not horribly difficult, really. First of all, we know its amplitude is 2. We know it's going to rise as high as 2, and it's going to go down as low as -2. Maximum value will be 2, minimum value will be -2. Omega is 4. So the period of this thing is going to be 2 pi over 4, better known as, again, as we said earlier, pi over 2. So this thing, we have to squeeze one entire cycle into the space from 0 to pi over 2. It's going to be squeezed into this space. And it has an amplitude of 2. Now, to squeeze it into the space, there's some key points. Anytime you have a sine function, you've got this point right in the middle of it. Then you've got this point in the middle of the middle, and this point in the middle of the middle. What in the world does that mean? Well, what's halfway between 0 and pi over 2? Halfway between, let's make that readable, halfway between 0 and pi over 2 would be pi over 4. Half of pi over 2 is pi over 4. So we know it's got to go through this point also. And of course it has to go through 0, 0. But then where will the maximum points be? The maximum point between these two would be halfway between. Well, what's halfway between 0 and pi over 4? Yeah, that would be pi over 8. So at pi over 8, we have a point way up here. And here at, 3/8 pi, we have a point way down here. And now we just connect our points with a nice sinusoidal curve. And it looks kind of like that. But then don't forget, remember, when you're graphing these things for me, don't stop there. You stop there, it makes it look like you think that there's only one cycle. There is not one cycle. How many cycles are there? Yeah, it's infinite. So I expect you to show me an infinite number of cycles. Well, no, you can't do that. That's silly. Yes, I know that's silly. But you need to show me enough cycles that I know that you know that there's more than one. So we would do another complete cycle in the next half a pi, going through this point, and then halfway between these two, going through here, and halfway between these two, going through there. And so we draw another one. Ooh, that was pretty nice. And also to indicate to me that you know that it also goes in the negative direction, I expect you to do one down here as well, like this, and then up to halfway here and all this stuff. And you've shown enough to convince me that you know what's going on. Good job. Look at that. You did it. Well, actually, I did it, but you could have done it. All right, that's what this whole part 2 of the section is about. So let's see their first actual example here. Oh, where is their first actual example? There's one. There is, by the way, a list of steps at the top of page 393, but the steps to graph these things are, I don't know, pretty intuitive, I think. Basically, it says find out where your ends are, then divide it in half, then divide the halves in half, and put in your curve, and you're done. That's what the blue box at the top of 393 basically says. So let's do, we just did that one. Let's find a new one. We just did example 5, really. Let's flip the page then and look at example 6. Can I delete this without killing my graph? Oh, no, I cannot. Bummer. Let's put that back. Can I erase without, no. I didn't lock that thing. Tell you what, I'm going to take a moment to reopen this file. Don't save. Okay, reopen. And this time, what file was it? That was the, okay, that's the wrong folder. Hold on a moment, I'm sorry. Yes, you're watching me flounder here, that's all right. I like flounder. Fried flounder is wonderful, but I don't like floundering. Here it is. And I am going to now be wise, and I am going to select the whole thing, and I'm going to lock the whole thing, lock in place, and that settles that. Now I can't erase it. Good. All right, back to work. Sorry about that little interlude there, interruption. Let's graph y equals 2 times sine of negative pi over 2x. Negative pi over 2x. Interesting. Now, first of all, we have to recognize that there's a little trick here that you don't want to forget. Remember from, I think it was back in section 6.3, we had that rule about the even and odd rules, the negative sign rules. Was that the even and odd rules? Anyway, for sine and tangent, you simply grab the negatives and take them off to the side. For cosine, you just drop the negative. So for sine, we take that negative and simply move it out here to the side. So we have y equals -2 sine of positive pi over 2 times x. That's what we're actually graphing. What's our amplitude? 2! That's right. Oh, isn't it -2? No. The amplitude rule is it's the absolute value of a amplitude. I should use the word amplitude. Amplitude is absolute value of a. It's the absolute value of -2. The amplitude is referred to as +2, which tells us again it's going to go as high as 2 and as low as -2. Maximum value will be 2. Minimum value will be -2. Now, what about this? We need to know its period. To find the period, we take, 2 pi over omega. What's omega? Omega is the coefficient of x. Omega is pi over 2. Pi over 2. Ooh, that's ugly. No, come on. You've been doing this since you were little people. How do you divide by a fraction? Yeah, you multiply by the reciprocal. This becomes 2. 2 pi times 2 over pi instead of pi over 2. The pi's cancel. We have a period of 4. Oh. Just when I had to lock this so I can't get rid of my numbers. Silly timing on that. Tell you what, I'm going to sketch this thing. Yes, here I go floundering again. I should have stopped this whole thing and restart, but I don't have time for that. So I am going to instead copy this, go to a blank screen. I'm going to paste it. There we go. That's what we're graphing. And we're going to just do a rough sketch like this. So we just established that it has an amplitude of -2 because it's the same thing as y equals -2 sine of of pi over 2x. We decided that the period is 2 pi over pi over 2, which gives us a period of 4. So, 1, 2, 3, 4. This thing has a period of 4. Of course, you know what a sine function looks like by this time. If it has a period of 4, it has to pass through the x-axis again halfway in between. So it's going to pass through this point. By the way, it has an amplitude of 2. But what's that negative do to it? Do you recall? That negative is going to take the whole thing and flip it upside down. So instead of doing this, our function right now is going to do that instead. It's going to flip it upside down. So I'm going to start by going down instead of my usual starting by going up because it is negative. So let's see if we can graph this thing now. We know it goes down, has a magnitude of 2. Oh, I forgot to put a negative sign here. Has a magnitude of, I'm sorry, I keep saying the wrong word. It has an amplitude of 2. Halfway between these points, it has to have a minimum value down here. So it goes through 0, 0. It goes through, this is 4. It goes through 2, 0. It has to go through 1, -2. Then it has to have a maximum point between these two zeros. So it has a maximum point up here. And that's about all we need. Connect it with a nice smooth curve, and we've got it. It's done. Well, sort of done. We do want to continue it. Oh, I missed. And continue it over here. I'd like to see at least 2 full cycles. If that's 4, 5, 6, 7. So we need to go through this point, and we have another minimum here. Okay, and that's adequate. So there we have it. That was example 6. Let's see what's going on with example 7 here. Example 7 asks us to graph this guy. Oh, this one's good. Let me just check in advance and see. Yeah, they're doing it to us again. They're giving us these whole number periods instead of periods in terms of pi. And that's okay. We have y equals -4 cosine of what? Of pi x. Alright. Clearly it has an amplitude of 4. It's also going to be upside down. But it's cosine, not sine this time. Remember what cosine looks like, and it is your job to remember. Sine normally starts here, while cosine starts up here and goes like that. So just remember, sine starts at 0, cosine normally starts at 1. That's from the previous video. So watch that again if you're unsure of how that works. So this is going to be upside down, has an amplitude of 4. What about its period? We'll take 2 pi and divide by pi. So this thing has an amplitude of, not an amplitude, get my words straight here, has a period of 2. Now we're ready to sketch it. Period is 2. Amplitude is 4. And by the way, when you do these for homework, don't just use homemade graphs like this. They're not accurate enough. And I've seen some of your artwork. Some of your artwork is very good. Some of your artwork looks like something, well, I won't say it. I don't want to insult you. But use real graph paper and make your graphs reasonably accurate. Use real graph paper and use the real graph paper properly. All right, amplitude is 4. 1, 2, 3, 4. -1, -2, -3, -4. Positive 4s. We have cosine. Cosine would normally start up here. Sine would start here, but cosine would start here. But watch out, because this is -4, so we don't start here, we start down here. So there's our first point. We have a period of 2, so we go 1, 2, 3, 4. Our period is 2. We need to squeeze 1 full cycle into the space of 2. So this is a little bit trickier doing cosine. Cosine, it doesn't pass through this point halfway between, but it has a maximum value halfway in between. Let me think about this. Make sure I don't say something silly here. Yes, it's going to have a maximum point above 1 and a minimum point below 2, because it has to look like this, starting at -4 and ending at -4. So halfway between these 2 points, we have the maximum point. Halfway between the minimum points, we have a maximum point. And halfway between this maximum and this minimum, guess what it has to do? Yeah, it has to pass through the axis. So we're going to have an x-intercept of 1/2, as it does this. And then it has to have another x-intercept halfway between these points. So it's going to do that. And we've got the basic graph. Then we repeat that pattern. We had a maximum at 1 and a minimum at 2. We'll have another maximum at 3 and another minimum at 4. And we just kind of continue this pattern. And we go in the negative direction. We'll have a maximum at -1 and a minimum at -2. So we'll do something. I just messed up there. Yeah, I messed up big time. Maximum at -1, and a minimum at -2. There's your graph. So with cosine, you just have to be careful, because if your period is from here to here, just remember cosine doesn't quite look like sine. Cosine starts down here, and it will end over here with the space of my period, which is 2. So between here and here, it has to go from the minimum to the other minimum. Why minimum? Because it's negative. It's flipped upside down. That puts the maximum halfway between the 2 minimum values. Makes sense? There. And then the zeros halfway between those, here and here. Connect your points and keep going. Not too bad? Yeah, not too bad. Okay, let's see. Example 8. Oh, for example 8, they're changing things up on us here. Again, they're using integers rather than values of pi. Okay. They give you the graph and they ask for the equation. What? Yes, really. So this thing goes through negative 1/4. It goes through positive 3 up here. It goes through positive 1/4. It goes through 1/2 negative 3. 1/2 negative 3 right there. It goes through 3/4, 1/4, 2/4, 3/4 right there. It has another maximum point at 1, 4/4, 1, maximum point up here. And their graph kind of looks like this. Our job is to figure out the equation of that. I missed. That was pretty bad. It should have gone like this. Okay. So, for the equation. This thing is clearly not sine. Why do I say it's clearly not sine? Because it doesn't go through 0, 0. This must be cosine. So we've got ourselves a cosine function here. It has an amplitude of 3. It's right side up. It doesn't start down here. It starts up there, so it's positive 3. The only thing missing is we don't know the value of omega. So we kind of reverse engineer that formula. We know that the period is 2 pi over omega. But this time we know what the period is. We can see it here. The period is from here, 1 complete cycle, to here. The period is 1. So, if the period is 1, we solve this equation, that 2 pi over omega equals the period, as always. But I need to know what omega is. So I solve this for omega. A quick observation says, oh, wait a minute. If 2 pi over omega equals 1, then omega must be 2 pi. Yes. Or you could use some algebra, but either way, you'll find out that omega is indeed 2 pi. So we insert here a 2 pi, and we're done. We wrote the equation. Pretty cool. Based on the amplitude, which is really the simple part, and then taking the period that we just observed from the graph, and set that period equal to the period formula, which is 2 pi over omega, and solve for omega. We find out that omega is 2 pi. Stick it right there in front of the x, and you're done. Not bad. Not bad at all. And do we need to look at example 9, or is it just more of the same? Example 9 is more of the same. Instead of taking your time for it right now, I'll simply ask you to look at example 9 for yourselves. What I would do if I were in your position, to make sure that you clearly understand it, I would go to page 396. I would look at the graph of example 9, and I would try to figure out the equation before looking at their solution and see if I got it right. Give it a shot. All right, so part 2 of your assignment. Yes, we're now ready for the next assignment. This assignment, let's see, I'm going to be giving this to you tomorrow, which is Friday. Actually, from your point of view, it's today. Yes. But because of Easter break, this won't be due until the following Monday, which is April, checking my calendar over here, it will be due on April 13th. So your assignment on this, due by noon on Monday, April 13th, not this coming Monday, but the Monday after Easter break. The assignment will be, have I figured out what it's going to be yet? No, I haven't. Oh, no. Let's see, what shall I give you? We just finished up through 42, so let's go with page 398. Page 398. Numbers what? How much do I want to torture you with this? Let's go... No, we haven't talked about how to do those. Okay. We'll skip them for now. Although they wouldn't be too hard, but let's skip them. Let's look at numbers 44 through, come down to 44 through 54 even. It's not over yet. Then we're going to skip over those we haven't discussed yet. There are quite a few of them we haven't discussed yet. Oh, that's interesting. They're giving you some really ugly ones here. Man. Sorry to be taking so long. Okay, let's jump now down to 68 through 78 even. 68 through 78 even. All right, there's your assignment. Due by noon on Monday, April 13th. I left out the L. April 13th. That was probably bothering some of you. Sorry about that. Don't email me about it. I fixed it. Noon Monday, April 13th. Page 398, numbers 44 through 54, and 68 through 78 even. When you turn in your assignments, please make sure that you do put the word Precalculus in the subject line so I'll know it's from you. And I also like to have the page number to differentiate it from other assignments. So 398, actually this is 398 part 2, isn't it? No, the previous assignment was actually on 397, so that works. Just call it page 398. Page 398. Okay, that's it. And by the way, in case I haven't mentioned it before, you can see all of the videos on my YouTube channel, which is simply called Gene Peer, with a space in between. Go there and browse through the videos, look at whatever you want. See you later. I feel like I'm forgetting something. I gave you the assignment, I told you the due date, we covered the material, there's nothing else to worry about. We're cool. Okay.